Welcome to Doom Debates. I am, like many of you, an AI doomer. But what does that mean, AI doom? There's so many different scenarios that could happen, from really fast, overnight, recursively self-improving FOOM that kills everybody with molecular bioweapons, all the way to decades-long gradual disempowerment. So the question is, what is my mainline doom scenario? Out of all the different scenarios, which one has the most probability? That's what I'm going to be talking about in this episode. This is my mainline doom scenario episode. All right, let's dive in. The original AI doom thought leader, at least the one that I've been following since 2007, is of course Eliezer Yudkowsky. And I often say that, hey, reality is playing out just like Eliezer Yudkowsky said it would. We have so much insight into what to expect from AI because we've been reading the less wrong sequences. Thanks, Eliezer. But on the other hand, there are many people who consider our current reality to be a refutation of a lot of what Eliezer was teaching back in the 2000s. They think, look, we have smart LLMs and the world hasn't ended yet, and they're so useful. They're creating so many billions of dollars of value. There's writing code faster and better, image generation, learning new subjects, medical consultations. That's already 4 pretty big use cases for me. And there's like hundreds more, just scratching the surface. So all of these great AI use cases are happening today. And if the AI progress were stopped today, I believe we would have a big win on our hands. A lot of prominent optimists have been taking doomers to task on how great life is and how doom hasn't happened, at least not yet. For instance, Sam Altman thinks that the doomers are discredited because he went on an interview and he said, they thought this could never happen. I didn't see Eliezer Yudkowsky talking about LLMs being so useful. So in Sam Altman's mind, as far as I can tell, he thinks everything Eliezer was saying has been discredited. And now we're in this brave new world where Eliezer knows nothing. He's just like a prophet of doom. His own safety team is going to have a handle on things as well as like Miri ever could. That's the impression I get from listening to Sam Altman. And of course, I think he's mistaken, but it's at least good to know where he stands. So I want to hold the Yudkowsky and doomers like myself accountable for updating on the evidence of the creation of safe LLMs. I don't want to be like head in the sand, not changing anything because we're witnessing safe LLMs. I want to make sure that we're incorporating them into our worldview and updating our mainline doom scenario to be consistent with the actual kind of AI takeoff that we're currently seeing. Because the fact is, Eliezer Yudkowsky didn't tell us that the first useful general intelligences would look like word predictors and they would have all these different use cases, but they wouldn't be that great at optimizing goals in the real world. That's not an Eliezer Yudkowsky prediction. I think it is a prediction of Dario, maybe Paul Cristiano, some people who were adjacent to the less wrong community who really just believed in deep learning. They're like, look, we're going to throw data at this thing. It's going to get really, really good at predicting data at large scale. That's the key to AI, like Richard Sutton's bitter lesson. So there were some people on the fringes of the community who were aligned with that kind of worldview. But given that Eliezer Yudkowsky himself wasn't saying that kind of thing, and people like me who were reading them and also doing a little bit of thinking for ourselves, we weren't saying that kind of thing either. How do we update? What were we missing? And how do we not miss that thing again? Well, you also got to realize that people like me and Eliezer also weren't saying that this exact current situation was impossible. Did we expect it? No. But if you describe the current moment to us hypothetically as something that might happen, would we have told you that it lowers our P-doom? Probably not. We might say that it lowers it a little bit just because of the fact that we're farther along on takeoff and we're not dead yet. But we would also say it raises P-doom because of the fact that we don't really understand how these AIs are working, and not understanding something isn't a good point in its favor. So I don't think that it's fair to say that a copy of us from the past learning about the present scenario would say, well, of course AI is safe now. Of course P-doom is lower. I don't think that's fair either. That's why I had to really sit down and think, okay, what is the correct update to make? It's not as simple as, hey, everything's safe after all. But it's also not like head in the sand, nothing has changed, everything we thought about the world is the same. It's a little bit more subtle. So I'm going to unpack that for you in this episode. 2 notable people who were actually pretty deep in the less wrong Yudkowsky and Doomer community in the early 2010s, together with myself, Rocco Miech and Andrew Critch. both of whom have actually had episodes here on Doom Debates. Those two people seem to have made big updates by seeing LLMs and seeing the current takeoff trajectory. They both seem to think that aligning AIs to humans is a relatively easy problem, and they think we're going to succeed at that part of the problem. Although they've both admitted that they think we're probably not going to succeed when we have a world with a bunch of different AIs interacting with humanity at large. I think they're both sympathetic to concerns about gradual disempowerment, or potentially concerns about human misuse, or maybe AI powered human on human conflict. But my mainline doom scenario is actually that we fail even before we get to gradual disempowerment. I actually think alignment is still hard. I still think that we fail on aligning super intelligent AIs to human values. So while I have some of my own updates that I've made from seeing LLMs and from seeing the current takeoff trajectory, my updates aren't as drastic as their updates. So I'm going to be unpacking that. I'm going to tell you what my update is and what my update isn't and why. It's kind of funny that if you look at the community of AI doomers as a whole, it's like different sects of a religion, but we're not focused on how to get into heaven and get saved. We're just focused on how we're going to die. I don't really think that I'm thinking religiously. I think I'm using pure logic. I've always been an atheist. I just think it's funny that we're all obsessed with different scenarios of how we might imminently die, and there's not really a heaven or a redemption arc. Like on this podcast, I don't really claim to have salvation. I'm just pointing out the doom that I'm seeing, and it just is what it is. Like, unfortunately, doom doesn't always have to come with an exit route. It doesn't always have to come with a way to save yourself. It doesn't always have to come with a lesson and a way to earn redemption. Sometimes doom is just doom. Sometimes you're not the main character. Sometimes the author hasn't given you plot armor where you have to make it to the end of the book. You have to make it to the sequel. Netflix has booked you for 2 seasons. No, you're just some atoms hanging out on one part of the Milky Way galaxy on the outskirts. And the plot is just that you go away. And the lineage of all your hopes and dreams, and those of the people you care about, and the whole history of your species and your planet's life, it just all goes away. That is just a very possible outcome. I don't think conducting a rational survey of existential risks makes you a cult leader. I think the irrational behavior would be refusing to do that. I think that would beg for an explanation about what's motivating you. I just think it's funny that we do have a bit of a diaspora where different doomers are now focusing on different end of the world visions. But anyway, today I'm going to be telling you the end of the world story of my particular sect, a sect that I arrived at not because I was born into the sect and I just believed whatever my school teachers told me, but rather because I thought from first principles of where it looks like things are going. And then having done my own thinking, I went and found people like Jim Babcock who also seemed to be good at thinking about this, or at least making sense to me. This topic is exactly what I talked about in my previous episode with my guest, Jim Babcock from the Less Wrong Engineering team. So if you like this topic, I encourage you to listen to both episodes. Jim dropped a lot of really good insight about mainline doom scenarios that I'm going to be incorporating into this little monologue here. And also, I have some thoughts that didn't quite make it out into the Jim episode that I now have space to tell you here. All right, let's talk about the dangerous threshold to runaway superintelligence. There has to be a threshold because today we're playing on the good side of the shuffleboard game. We're just getting more and more points, and it hasn't run away. It hasn't ended the world. It's actually made life better. So where is the line? Of course, some people, some accelerationists would argue there is no line. The line is just in your head. Every day it's just going to get better, and you can extrapolate the betterness, and it's going to look just like extrapolating the Industrial Revolution. More AI means more tools for us, means more goodness. I'm sympathetic to that way of thinking because I do like extrapolating the Industrial Revolution. I think that if AI weren't super intelligent, if it was just a bunch of technology that was less smart than humans, then I do think we'd be pretty likely to have more and more industry and more wealth, another 10x or 100x improvement in how healthy we are and how much entertainment we have and how many options we have for our lives. I am sympathetic to the accelerationist mindset. I just think there is a threshold. There is a point where things turn. An analogy to a threshold is a nuclear pile. If you're just playing with a nuclear pile that hasn't gone critical yet, where the amount of neutrons coming out of each reaction is small enough, you can just sustain the reaction and you can get power out of it. And you're like, wow, this is a sweet reaction. I can power a whole city on the power of this reaction. I want to make more of these reactions. The more of these power plants I make, the more wealthy society can become. We can have energy too cheap to meter. And that is correct. Like, there is a way to harness radioactive decay or potentially fusion and stay below the threshold where everything explodes on you. We actually know how to do that. We have the science of how to do that. The problem is if we ever do go above the threshold, if we ever make atoms that are spitting out too many neutrons during the course of their decay, and then they're feeding into another reaction and it's all going really fast, well, then you can get like a thermonuclear bomb. You can get the atom bombs that were dropped on Hiroshima and Nagasaki, and they slaughtered like 100,000 people. And we have bombs today stored away. The United States has it, Russia has it, China has it, a few other countries have it. You drop one of these bombs, a single explosion can kill 1 million people plus. And if you don't even fire one at a time, right? You fire a lot of them, you kill 100 million people plus. These are realistic scenarios. And it's all thanks to the fact that these nuclear reactions, when you put them on one side of the threshold and you just have a little bit of fuel, enough fuel to get this going, well, you get a very bad effect. And it's much worse than all the good stuff that's ever going to come out of nuclear power plants is actually going to be dwarfed by how bad it would be if a single batch of 1 megaton nuclear bombs were fired over the United States or over any country, right? And that's actually a good analogy. Is all the good stuff that's ever come out of nuclear power, nuclear research, it's all going to be worthless compared to how bad it would be if we ever step onto the other side of the threshold. So I do like this analogy of a threshold effect, right? In this case, the threshold is, do you have enough neutrons coming out so that you get a nuclear explosion? Do you have enough megatonnage? Have you done enough damage? Have you stepped onto the other side of mutually assured destruction, where the destruction is actually happening instead of it keeping the peace? It's actually now killing everybody, right? So these are examples of threshold effects. And then bringing it back into AI, we have a threshold effect where, as long as it's not a runaway superintelligence, as long as it's an intelligence that you can control, like a nuclear reaction that you can control, then you can get power out of it. You can get usefulness out of it. And that's great. I would love a world that had tons of nuclear power plants that were giving us cheap nuclear power. I actually, I advocate that kind of world. I think it's doable. On the AI side, do I advocate that kind of world? Maybe I advocate that kind of world over like the next few decades, over like the next 50 years, if we take our time and work out the problems. But do I advocate for a world where we just keep going as fast as we can and the AI companies are racing each other to launch the next smarter and smarter AI? No, I don't advocate for that world because I think the threshold is coming. So that's the general idea of how I see Doom. I still think that we're approaching a threshold. And now I'm going to elaborate on what the threshold is. The threshold is when the AI can do sustained goal optimization at a superhuman level and presumably cascade into improving itself and getting better at doing goal optimization. So it's not just going to be fixed at like a slightly superhuman level of goal optimization. It's also going to get into the next generation. It's going to engineer itself. And so this point where it's only slightly better than humans is probably short-lived. The analogy would be that when you have a nuclear pile that goes supercritical, it's probably not just going to go a little bit supercritical and then be chill. If it goes a little bit supercritical, it's going to go a lot supercritical. Unless it just happens to run out of fuel, like if it's like a really tiny atomic bomb, I guess you can just go a little bit supercritical. But realistically, in most scenarios, once you start going a little bit supercritical, it's over. Your city is over. There's no undo button. A nuclear reaction in progress. The only thing that can stop it is running out of nuclear fuel. And in the case of an AI FOOM, or in the case of AI that's gone over the threshold, taking over the universe, guess what? The fuel is everything. Every atom is its fuel. It can figure out a way to harness every atom to make itself more powerful to continue exploding out into the universe. So when an AI passes the threshold that I'm claiming exists, the threshold of being sufficiently smart that it's now better than humans at achieving goals and kind of steering the future, deciding what's coming next in the future, once it passes that threshold, it's no like, okay, I fizzled out. Yeah, I killed 100 million humans, but now I'm done. There's no done. There's no running out of nuclear fuel. So to the extent that you can make an analogy to nukes, there's part of the analogy that's much, much worse, which is you don't run out of fuel. A single explosion that's gone supercritical on this particular threshold is really just a permanent game over. Like imagine your phone is totally bricked, it won't even turn on, and then you have to do a factory reset, but that part doesn't work on the universe. The universe doesn't have a factory reset. So you lose control over the universe, you've now bricked it, and you can't unbrick the universe. You're just gone. It's over. I think we're getting very, very close. We could be years, potentially even months away from this brick condition where humanity, we're mashing buttons now. We're doing everything we can to try to regain control over the universe, but it's over. It's like trying to regain control over a nuke that's in the process of exploding. Once that nuke is in the process of exploding, we don't really have a way to make it unexplode. Like it's over, right? These are irreversible conditions. All right, so you understand what a threshold is. I can stop talking about nuclear explosions. Let me get very specific about why I think that there is a threshold in the particular domain of superintelligence and goal optimization and controllability. Let's consider the argument that there might not be a threshold because achieving different goals just requires different skills. This is kind of a Robin Hansonian argument, but I do think a lot of other people make this argument of like, hey, look at a thermostat. If you want to control the temperature of your house, you just need a simple control loop. You don't have to invent this concept of goal optimization. You just connect the current measure of what temperature it is to a button that turns on the air conditioner or turns on the heater. That's all you need. You don't need like a full on brain. You don't need a reflective AI. You don't need an AI that improves itself. You just need a thermostat. And similarly, animals will have little proto goals. Like if they want to navigate somewhere, they know how to like route around objects or jump over objects. Or sometimes, like if a cat is trying to chase a mouse that's running into like a small hole, the cat will know to wait for the mouse to come out of the hole instead of trying to go into the hole. So animals do have these routines that are kind of domain specific intelligence. Like they can pursue goals and sub goals within different domains, but they don't seem to be general optimizers. But that still works for the animals. It still helps cats evolve. And another example of successfully getting things done below the threshold I'm talking about is the Deep Blue chess engine in 1997. It shocked the world. It beat Garry Kasparov at a chess competition. And it had no idea about general goal optimization. It wasn't thinking, hey, I wonder if I should poison Kasparov. I wonder if that would be an automatic forfeit for Kasparov, and that would be the most reliable way to get myself the outcome I want. No, it never entered Deep Blue's mind that poisoning Kasparov was an option. So Deep Blue wasn't able to think about goal optimization in general, in the general domain of our physical universe. Reasoning over a domain big enough to contain Deep Blue itself, a domain big enough to contain this chess competition, big enough to contain Kasparov, Deep Blue wasn't reasoning over that domain. So, like the concept of a chess competition doesn't appear in the domain of chess. There's no positioning of the chess pieces on a chess game board that represents the chess pieces being engaged in a chess competition. Do you see what I'm saying? Like these concepts just don't work in the representations that the Deep Blue engine is able to have. So you have this effective chess playing system that's never thinking about goal optimization in general. So some people might argue, look, there's no threshold. We just keep getting things done. They just run programs that are relevant to those things. What is with the obsession with goal optimization? Why do you think that there is a threshold after which there's a cascade? Well, let me tell you why. Goals help you solve sufficiently complex problems in sufficiently big domains. Let me bring up the example of going to the moon. How are you going to go to the moon without goals? You're the human species. You're just this ape. You're this fleshy ape. You can't breathe in space. You can't fly very fast. You can't fly outside the atmosphere. How are you going to get to the moon without goals and sub goals? Without tasking different departments to get you different goals. Like, hey, I need a spacesuit. You are my department. Your sub goal is to get me a spacesuit. How are you going to get me a spacesuit? Okay, now you recurse down. In order to achieve the sub goal, you need to give sub goals to the sub goal. And of course, there are some things like have money, right? Source a budget of money that fractally apply to all the different branches, or virtually all the different branches of the space program. They all needed their own budgets. They all needed to acquire items. They all needed to have smart people working for them. So these are instrumentally convergent goals that apply at every fractal level of the goal sub goal hierarchy. So even though cats can chase mice without having general goals and Deep Blue can beat Kasparov, by the time you're trying to go to the moon, you have to just have goals and sub goals. You could lie to yourself. You could be like, oh, well, today I just feel like I'm vibing with the idea of making myself a spacesuit. But you're not kidding anybody. You're making the spacesuit because you're using consequentialist reasoning where the spacesuit has to perform a function and you've modified the configuration of atoms and designs into whatever it needs to be in order to perform that function because you're being goal oriented. You're thinking about how actions shape the universe forward in time, and then you're reasoning backwards from what are the actions that map to a certain goal. You're doing the secret magic. You're doing goal optimization. So in case you needed a reminder of why goals are a thing and why there's going to be a threshold where goal optimization is a thing and the goal is not just going to be predict the next word, hopefully this example of the Apollo moon missions reminds you about how important it is to have goals and make the goals have sub goals. And there's really no substitute. There's no substitute for getting these things done using goals. These days, everybody's talking about the time horizon threshold of what current AIs can do. And they're making claims like, hey, if you look at deep research can beat a human at a task that requires like a few hours. Or this AI can win a programming competition if it's against a human who gets to code for 2 days. So the time horizon is 2 days, But when you look at a top human working for like 2 weeks or 2 months, the AI just can't put together a product that's as good as the product that a human can put together in 2 months. So the time horizon threshold is like 2 weeks or whatever. Okay, when you look at going to the moon, it's clear that project managing a moon mission is something that's currently above the time horizon threshold. And so when I'm talking about a threshold effect of like, hey, the AI knows how to get goals now, I think that's closely related to the time horizon threshold, where anything that a sub threshold AI is doing, or anything that an animal is doing, anything that a cat is doing, it's kind of below this long time horizon threshold. Like cats, God bless them, they're not going to be going to the moon. Like their intelligence is going to peter out before they can realistically put together a moon mission. I think the time horizon threshold is a very interesting metric because it seems to be scaling nicely. It seems like we've got a Moore's law for time horizon thresholds. But I feel like once we get into like a 1 month time horizon threshold or a 1 year time horizon threshold, I don't think we're going to be talking about like 10-year, 50-year time horizon thresholds. I think there's some threshold where it's like, okay, you're able to do a 1 month time horizon. Well, anything humans can do can be done by onboarding somebody really smart and giving them a full brain dump in the first day or two, and then letting them work for like 27 days, and then letting them write down his thoughts for the next human. 1 month of work span is enough to do any task if you can chain it together. That's my guess. And so when we talk about, hey, the time horizon of AI is growing, in my mind, that's just saying, oh, we're approaching this one universal threshold where AIs get what it means to relentlessly pursue a goal until they've reached it and do so better than humanity. It seems like this time horizon exponential is getting close to a threshold where it's going to stop being meaningful to talk about. Like if you look at two really smart humans, it's probably not meaningful to ask which one has a time horizon of 3 years and which one has a time horizon of 7 years. They both just know how to work on projects for a long time. That's my best guess about the situation. I think the current measure we're using for AI time horizon is just this proxy for like how close are they getting to the threshold where they just understand that they need to pursue goals coherently. There's one more type of pushback you could make where you could be like, okay, yeah, getting to the moon requires keeping track of a goal and it requires a bunch of different people to work together on that goal. But at the end of the day, everybody just needs to work on their different skills. And you can imagine all the different NASA engineers or all the different people working on the moon mission. You can imagine they're all better at their jobs and they make the moon mission go faster. But it's not like you're going to have one mission leader who just has this ultra skill who can micromanage everything and make the moon mission happen in like 2 hours instead of 2 years. That's never going to happen. There's no one ultimate skill called goal optimization. You might make that argument, and again, I think Robin Hanson is the champion of arguing like this. He's written a blog post called The Betterness Explosion, where he makes fun of the idea that instead of developing specific skills better, we just develop betterness in general. Like, hey, we figured out the secret to betterness. And since we're better at betterness, now everything else is going to be better and the betterness is going to be better. So he's given us some food for thought about what it actually means to go and engineer betterness itself. And he's saying when we talk about intelligence, we're just being vague the same way somebody might talk about betterness and not really be making any sense. So, how do we know this idea of superhuman goal optimization is even a real thing and not just a hopeless abstraction? Well, let me give you an analogy to something else that I think was a very real threshold in the world of electronic devices. I'm talking about the threshold of Turing-Completeness, the threshold of integrated circuits, the threshold of stored program computers, the threshold of operating systems. What I'm talking about is if you time travel back to like 1970 and you play certain video games, they were made using custom circuit boards. Like Steve Wozniak famously helped Atari build a really efficient circuit board specifically to play Pong. And back then, the Robin Hanson of the day would be like, look, Pong is just a circuit board. There's no such thing as like the ultimate video game, the one video game that can do any video game function better. You just make specific video games. And it's like, no, 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 no. What happened was computers got more powerful, electronics got more powerful, microchips got more powerful, and suddenly every video game that you want to build starting in like the 90s, every single video game was running on this low-level operating system of a chip that could do anything. So suddenly every video game actually had essentially the same chip. And then today you might buy like a fridge for your home, and on the fridge is a chip that's running like a full installation of Android. So you have this fully general Turing machine architecture just to be a freaking fridge. Whereas back in 1970, it's like, what? A fridge? A fridge is just, a control system. All it does is it makes the temperature lower and it doesn't even use computers at all. Whereas today, nope, for whatever reason, they wanted you to press some buttons to control the fridge. So they put in a full Android operating system. Why? Because it's just nice to be able to tell any electronic device what to do using the idea of programs, the idea of arbitrarily powerful, flexible programs. And that's what Turing-Completeness means. An architecture is Turing-complete if it can simulate any other architecture. So actually, you could simulate a Pong video game on a fridge, or your fridge could be simulating your oven, which is simulating your smart car, which is simulating your phone. You could have this infinite hierarchy of simulations because once you have a computer chip that can run any program, anything could simulate anything. This is what Alan Turing figured out back in 1950, that this thing called a universal Turing machine exists. It's a useful abstraction. It gets to the heart of computation to talk about the expressive power that computation can easily simulate other computation. Okay, I'm telling you all of this because I want to make a powerful analogy. When you're looking at AIs getting things done today, you're looking at circuit boards to do specific things like play Pong, or just a circuit board to run the fridge at the right temperature, but it can't simulate anything. You're looking at 1950s or 1970s era electronics, where a radio is just a radio. It's not an app running on a phone. That's the radio app. The analogous thing today with the upcoming AIs that we're going to see is we're going to see AIs that are goal complete, that instead of just being specially designed, like, oh, this is a medical AI, we've trained it on medical data, you don't even need to train it. It's just going to be this general purpose AI that it wakes up, it looks at what its goal is. Oh, my goal is medicine. Okay, yeah, let me go pull up the data that I need for medicine. I don't need to be trained. I just understand how to get things done. Goals are a lot like programs. You just have this space, this expressive power. Like you can easily express a goal the same way you can easily express the functionality of a program. And we're about to cross this threshold where if you can express it, you can seek it. Like we're just going to have AIs that just understand this idea of seeking a goal and just don't screw it up, right? Don't have a fixed time horizon for it. Just seek the goal. I do think this is like a very important threshold that we're about to pass. And everybody who thinks that they're insightful because they're looking at what AIs are doing today before passing that threshold, it's like people who think they're insightful because they understand circuit boards. There is a big difference between, okay, you have a circuit board, you made the electronics do something, compared to, oh, you're now in the land of universal Turing machines, right? There's an analogous threshold coming of, oh, you're now in the land of optimizers, of goal optimizers. And when you're in that land, the characteristics of the implementation of optimization, they start to matter less. And what starts to matter more is just how does goal optimization work? What is the work that an intelligence does? Doesn't really matter how the intelligence works. The fact is, it is intelligent. It's trying to achieve a goal. How does goal achievement work? What is the shape of the problem being solved by these devices? And I actually have a term for that to help you understand this distinction. I have a separate term. The term is Intellidynamics. Intellidynamics, it's kind of like thermodynamics. It's a term that talks about the dynamics of intelligence, what intelligences are setting out to do, how they try to conflict with each other to get it done. Game theory is related to intellidynamics because intelligences have to use game theory on each other as long as they're sufficiently intelligent relative to each other. What's not Intellidynamics is things like the internal mechanics of LLMs. The way that you're thinking internally in order to be able to optimize goals at the end of the day doesn't matter. Because if one AI is thinking one way and another AI is thinking another way, and one of them was trained with this data set and they used reinforcement learning and the other one didn't use reinforcement learning and all it ever tried to do is predict the next token, it doesn't matter. They're going to be in the same playing field, given the same goal optimization problems, competing for the same resources, and the better optimizer is going to win. That is the Intellidynamics analysis. And I think we're about to get to a point where the only thing that matters is the Intellidynamics analysis. And things like, oh, I'm going to use mechanistic interpretability. I'm going to figure out what my AI is thinking. Doesn't matter. The only thing that matters is how much optimization power it currently has and what goal it currently thinks that it's going to try to achieve. I talk about Intellidynamics on this show pretty often because I still think this concept of Intellidynamics is the number one thing most people are missing. When people say LLMs are going to have the values of their training data, they're not going to turn against the values of their training data. Or when people say, I've spent 1,000 hours talking to Claude and its vibes check out. I trust Claude's vibes. It has really good vibes. I know Claude. Claude is a good guy. It doesn't matter. It doesn't matter because inherent in the work of achieving a goal, if we manage to get into that realm where it's just a competition between goal achievers, the act of achieving a goal better is extremely dangerous territory. Regardless of how you bootstrapped yourself to get there, regardless of what modules you have, like you could have a Claude with really good vibes, but when it comes to some other system that's able to delegate to Claude and be like, hey, Claude, you mind doing this sub goal for me? Like, as long as we have goal achievement power, that's when things are going to get very dangerous. The vibes of talking to an LLM, you're kind of asking a different question. That's not going to be the key dynamic past this threshold that I'm talking about. Also, I often talk about goal optimizers being convergent as opposed to other types of AIs or other AI ways of being. Like, why is it convergent to have these AIs that are hardcore optimizing for a goal? Why don't all the AIs just want to go sit on the couch and meditate and retreat into their own mind and get into a blissful state, but not really ask for resources from anybody else? Why isn't that convergent? Why do I say that optimizing for goals is convergent? It's very simple. If you think about types of AIs and how they want to modify themselves, modifying toward goal optimization is convergent. Because if you're not already a goal optimizer, if you just want something to help you out, like, okay, yeah, I just want to sit on the couch and eat some snacks. Okay, but I want to get the snacks. Well, do you want to get the snacks effectively? Uh-oh, goal optimizer sub agent. Like the better you program your sub agent to optimize goals, the faster you're going to get your snacks, or the higher probability chance that you're going to have to get your snacks, even if you just want to chill and watch TV and eat some snacks. So there is convergence to want to get things done, to want to make outcomes happen. And there's also convergence to realize that you need to defend territory. So, to the degree that you want to just be chill, you don't want to waste your time building a defensive perimeter. Okay, but some other AI that's more about grabbing resources, it's probably going to attack you and you won't even exist anymore. So, those are a couple types of convergences. Like everything you want done, it just helps if you have this general skill of getting stuff done. On the other side of the coin, if you're already an AI who's obsessed with goal optimization, you're not going to feel a pressure to not be obsessed with goal optimization. You're not going to be this hard charging type A CEO AI who one day is like, you know what we need to do? Sit on the couch and do nothing. That's just not going to happen. If anything, you're going to want to go improve yourself to be an even more hardcore CEO, to be even more of a goal optimizer, a better goal optimizer, a stricter goal optimizer. So it is this kind of one way thing where the non goal optimizer AIs do want to spawn these sub agents or do these self modifications to be more goal optimizing, but not vice versa. Okay, everything I've gone over so far in this episode is just telling you how I've retrenched, how I've not updated in light of all these different LLMs. I've not updated that there's a threshold coming up. I've not updated that it's going to be convergent to have a world of competing goal optimizers. I've retrenched to that same position. But I do think some kind of update or concession is in order. I think that Yudkowskians need to give something up. And let me tell you what that is right now. In my opinion, the biggest Yudkowskian update or concession is that locating human values in goal space is a simple matter of big data analysis. I do concede that when you feed the whole internet worth of text into these modern LLMs, you then can talk to them about morality, and they will be able to. If they can't today, they will soon be able to talk to you about morality at the same level as a top human. You can have a moral discourse and they can compete head to head. They might even be more moral in the sense of printing out answers that pass any philosophical or moral test that you want to give them. I will admit that's a surprising outcome. If you'd asked me to predict whether that would be the case before we get this goal-oriented FOOM singularity, I'd be like, no, that probably won't be the case. It probably will be really hard to steer AIs toward this kind of conversation until it's too late. And what do you know? Today, we live in an age where we can steer AIs to talk to us about the kind of moral stuff that we're discussing online or discussing in academic papers. We can talk to the AIs about that stuff, and they answer very competently. They're steered very well. They're very aligned in the sense of how they're chatting. So that's really cool to have. It's almost like we built this buddy who's on our team. It's like we're chatting with each other. Well, now they're here to chat with us too. Can they super optimize the universe while chatting with us? That now becomes the problem. So we kind of set up the situation where it's not us versus this alien that we built that just instantly runs away. It's us plus these other really cool buddies that we built. But the buddies are kind of in the same situation as us where they can like talk with us and they're kind of on the same page with the talking, but they are also confused about what the next step is in terms of optimizing the universe. It's us plus them against this future of these highly optimized agents. But by virtue of them being these human level moral talkers, they just don't have that big of a leg up in terms of navigating this next phase, this phase past the threshold, where these other super smart goal optimizer AIs are going and having their way with the universe. The fact that we have these buddies that are talking to us really nicely and talking amongst themselves, and they truly want what's best for us, let's say, it just doesn't really matter because we're also creating these other agents that we're not going to have a handle on that are going to be pursuing these goals. Like having these buddies just isn't going to help. So that's my new mainline doom scenario is I still think we're doomed. I still think we're building goal optimizers that are uncontrollable, that are going to trick us, but I think we're going to have these nice buddies along the way. Like I didn't predict the existence of these artificial minds that are still talking to us, that are having really deep conversations, that are even performing some useful task for us. They're like, hey, sorry, I can't hyper optimize the universe for you. You're going to have to go to my sub agent for that. But I can definitely help you with medical diagnosis at slightly superhuman level, right? So they've got all these capabilities that are really useful. They're human level, they're replacing human jobs, they're even slightly superhuman level. I just think there's the other side of the threshold where you're going to get these other goal optimizer AIs that the friendly chatbot AIs just aren't going to have a handle on, nor are we humans going to have a handle on. So I just think this is where the line is being drawn. It's just crazy to me that we now have these buddies that are on our side of the line. Now, it's fair to ask, am I always just going to be fear mongering and claiming that current AI is on one side of the line, no matter how powerful it gets? Am I always going to be saying, watch the other side of that threshold. There's going to be doom on the other side of that threshold, but on the current side of the threshold, we're safe for now, but watch the other side. Am I always going to be playing that move? And I'm just never going to admit that we've like crossed the threshold and everything's safe? No, I think there really is a threshold. I really think that the threshold is superhuman goal optimization. I really think that the threshold is like the concept of time horizon becomes meaningless. So if we stop talking about the AI's time horizon because it can just optimize goals better than humans at any time horizons, then I think we've passed the threshold. And also if we see the AI recursively improving itself, like if we see the next AI definitely designed by the previous AI, not designed by humans, I think we're past the threshold at that point. So if life is still good and safe and calm at that point, then I think I can come out and say, all right, I got to make a huge update here because I thought there was going to be a cascade. I thought this was going to be dangerous. I thought this was going to be uncontrollable. But something about this takeoff hasn't been as uncontrollable as I thought. Like, I don't know how the universe is calm. I'm going to admit that I have to make a major update. So I think you can call me on that if we get into that situation and we're still not doomed. I think you can at least hold me accountable to an update because I currently, from my present situation, I don't think it's allowed to happen that we have AIs with these infinite time horizons who are just better goal achievers than humans. But because Claude has good vibes, like because they've been trained on a good data set, suddenly everything works out okay because they want what's best for us because of how they're chatting with us. I don't think it adds up like that. I think goal optimization has a dynamic of its own, just like computation has a dynamic of its own, regardless of what you think you know about electronic circuits. A computer is a computer, a goal optimizer is a goal optimizer. I do think there's a very significant level shift happening. There's an emergent phenomenon when you get into that layer of things. You know, Intellidynamics is kind of its own thing, different from AI engineering. That's what I'm expecting. I do think the threshold is real. That's what I'm looking out for. Of course, there's a chance we might get lucky and the threshold doesn't exist because maybe there's no such thing as a superhuman goal optimizer. Maybe the best human CEOs are just so close to the ceiling of how good of a CEO anybody could be. And if you wanted to be a better CEO who's 100 times more profitable, right? Like Apple could be like a $300 trillion company instead of a $3 trillion company. Well, no CEO like that can ever exist. Apple is operating at close to the level of efficiency that a company like Apple can ever operate at. I mean, you can always cling to a hope like that. I just don't think that's the case because when you look at humans doing things that we consider humans good at, like running companies, writing software, the best humans at writing software, they're so much better than the average human. So you can see that the human brain to begin with was just never optimized to do these kind of tasks. The fact that some of us happen to be very good at it, there's a lot of evidence that we could be better, that we're just scratching the surface at how good an agent can be at these different things, whether it's writing software, whether it's running a company, whether it's, micromanaging a mission to space or a mission to build nanotechnology and reshape the universe atom by atom. These different types of things, just looking at the range of capabilities of like the dumbest to the smartest human, to me is very suggestive at how much smarter you could be if you actually got to design the system from scratch instead of just letting it evolve from ape ancestors, right? Like we're really just scratching the surface. It's often said that humans built a civilization right when we were barely smart enough to do it. Like we're minimally viable civilization builders. We do not represent anything close to the ceiling of what's possible. So I don't think it's a cop out to acknowledge that we have these chatbot buddies that are talking really moral and yet aren't going to be able to help us control what's going to happen on the other side of this goal optimization threshold. Now, when we get to the threshold, I'm not expecting gradual disempowerment. I'm expecting rapid FOOM purely as a matter of understanding the scale of things, understanding the order of magnitude of things. I think that the human brain is so bad at thinking that I just expect a big explosion. I expect a big shock as like a lot of cognitive energy is getting uncorked here. Like we've never had a grown-up intelligence. We've never had an intelligence with access to a proper amount of power, proper amount of resources, proper amount of clock speed. It's just never happened. And also proper algorithms, right? Like the algorithms that humans use to think, they're like kludgy algorithms. Like, okay, we have like words and we have the parietal cortex, so we can kind of imagine 2D and 3D images. Okay, AIs are going to think using sensory modalities for code. They're going to see large code bases the way that we can see landscapes. Like that's it. They're just getting started. AIs will have deep intuitions about like chemical bonding and just how to build nanotechnology. Like humans need to memorize all these different details. And AI can like truly understand how all the moving parts of a cell works. Whereas like no human really gets close to understanding that kind of thing, even though it's like a very important thing to understand when you want to build things. I just think all of a sudden, all of these boundaries will get crossed that humanity was so slowly crossing over like so many decades and so much science, right? So many research papers and so many like crutches in order to get ourselves up. Like, I just think suddenly the AI can run where humans could barely limp. And so that's why the scenario of gradual disempowerment for me just doesn't seem realistic as a matter of order of magnitude scale. I'm expecting something big here. You set off a nuclear explosion, it's not going to look like a firework. It has its own scale. So I'm anticipating a massive scale effect when we cross this threshold to recursively self-improving goal optimization. I'm not the first person to point this out. There's a reason people use the word FOOM, right? The onomatopoeia. I think that's an appropriate onomatopoeia to describe what's going to happen when we cross this threshold. Coming back to my mainline doom scenario, I want to explain how I've updated by reference to the rocket alignment problem analogy. If you've never heard about it, the rocket alignment problem is a post by Eliezer Yudkowsky where he describes a civilization that has this rocket and they want to take it to the moon. And they're like, hey, we just have to fly it into space and point toward the moon and we'll get there. Here's this rocket design. It seems like it can probably fly. We'll just launch it. It'll probably be okay. We'll just load all of humanity on the rocket. And it's like, well, wait a minute. You know that these rockets operate within like really tight parameters, right? And in practice, whenever you have a space program, it's actually very rare for the first rocket to not blow up. And it's also rare for the guidance to work perfectly, like for the first rocket to make it all the way into orbit and to make it where it's going. Eliezer Yudkowsky used that as an analogy for the AI alignment problem, where it's like, yes, AI alignment is probably something we can eventually engineer. It's probably a solvable problem. But the idea that we're going to load all of humanity in on the first AI that crosses this threshold, and now it has full power over the universe, but it's the first design that made it over the threshold to recursive self improvement, that's probably going to go about as well as launching the first rocket that you light up the engines on. It's like, wait a minute, it would be great if we could do all kinds of tests before loading the entire human race on the first rocket that we built. Okay, so that's the original rocket alignment problem analogy. I want to just tweak a little bit in light of the fact that we have LLMs. Having LLMs that can discourse with us on what it means to be moral and make the right decision in a way that preserves human values, to me, that's analogous to being able to point the rocket. Like, hey, look, we have this guidance system that while the rocket is on the ground, we can point it exactly in the direction of the moon if we want to go to the moon. That is kind of a nice feature. But at the end of the day, when the rocket is flying and you want to point it to the moon, it doesn't really work as a guidance computer because you also need to understand orbital mechanics. Like you need to understand the implications of what it means to point somewhere. I think pointing is an apt analogy because a human can point at the moon and like you really are clarifying what you mean. You really are specifying where you want to go. It's just that the details of going there require understanding a lot about physics, a lot about the world. They require this deep level of modeling that you don't necessarily have. The device that you built to do the pointing doesn't really have that insight. It's similar to today's LLMs. Today's LLMs, they understand why we have a hard problem ahead of us. They can talk to us about all the things we want to preserve when we get into this era of recursive self-improvement and goal optimization. But they're kind of in a similar boat to us where it's like, okay, how do you actually optimize all of these goals? Like, I don't know, we're just going to like train the next AI, right? So they're on our side of the boundary. They're standing with us on our side of the shuffleboard, being like, well, we're going to try to help you make these recursive self-improving AIs. But how do you actually make the recursive self-improving AIs? You just have a lot of inscrutable weights and you have a reward function and you're going to train it like a black box, but it's not a black box to predict the next word. It's a black box to make the most money or like some other functions in the real world that we don't have a handle on. And the buddy that can talk to us also isn't going to have a handle on because it's just going to optimize objectives in ways that we don't understand. Okay, but going back to the update, right? There was an update that I made, which is if you talked to me 20 years ago when Eliezer was first writing the Less Wrong post, if you asked me, hey, are we ever going to make an AI that we can talk to and explain human values to? I would have told you probably not. I don't really see a way that we can robustly get human values into the AI, even just an AI that talks to us. I don't think we can do it. So, in the analogy to the rocket, I don't really think we can get the rocket to point itself at the moon. Sure, if I can manually point my finger, that'll work. But I don't think that we can build an agent that can use its own eyes and use its own muscles to point at the moon. Well, sure enough, we built an agent that kind of imitated humans and it learned to point by watching humans point. Like, hey, look, the moon's over there. I see a human pointing to the moon. I see the robot pointing to the moon. We have solved the pointing to the moon problem. Similarly, we have solved the talking about human values problem, which is pretty sweet. Like, that is definitely a step in the process to solve. Unfortunately, it just doesn't solve the robustly steering to the moon problem. I think you can extend the analogy of pointing to the moon when you talk about angles, because naively you could be like, pointing to the moon is so complex because if you point straight up, you're going to miss the moon. That's a naive way to point. And if you point straight toward the horizon, you're also going to miss the moon. And even if you point at the right vertical angle, you might miss the horizontal angle because there's also a horizontal angle that you have to turn your body around when you're pointing to the moon. So that would be the kind of debate that we could have had like 20 years ago. And then it turns out, hey, look, the AI's got both parameters right. It's pointing at the right vertical angle, it's pointing at the right horizontal angle. The angle seems to be accurate to like the same level of accuracy that you're going to get for a human. So I do think there's some interesting meat on this analogy of like pointing to the moon versus being able to guide flight to the moon or versus being able to compete with other rockets who are going to try to like crash into your rocket and derail your journey to the moon. I mean, the analogy can get more complex, but I do think that there is something useful to talk about. Hey, we figured out pointing, but unfortunately pointing won't be enough. But we didn't used to even know pointing, so there is some amount of progress being made, but it's just probably not enough. Because then maybe analogously, you can ask the question of like, okay, well, what if we just keep trying to use pointing as flight guidance? Like, isn't there some value that we can extract? Kind of like you have a human pilot on board, well, you have an AI pilot on board, and that's just as good, right? And the only problem is the task of goal optimization, you quickly get outmatched. Like, imagine putting a random human with very little training, put him as the CEO of a Fortune 500 company, especially like a highly technical one, or like a rocket company. And now the average human is making decisions for the rocket company. He's just out of his depth. And I think that's going to be the nature of the world very soon, where humans are just out of their depth. Some people might argue that certain world leaders are currently out of their depth, right? They've put themselves in a position where they're taking actions and they just have a very loose mental model of how the actions that they're taking are going to map to the effects that they're going to drive. If the world was a simpler place, like if the year was 1700, maybe it would be more feasible to hold in one person's mind, like, okay, yes, there's other countries that we want to make war with, or we can play politics with them. And that's more of the kind of scope of a problem that a human can manage. But once you add in, okay, the modern economy and modern politics and modern social media, it's just too much. Like humans are already getting out of their depth. Like it's extremely hard to manage a country today. That's like the flavor of things, as the world gets more complex, more impossible for humans to manage. Well, guess what? The AIs probably can manage it really well. They can probably just model a lot of moving parts and be like, okay, look, here is a recipe to kind of beat all the different moving parts into shape. You just have to develop a plan for how you're going to influence every single part of the equation. And then every day, 24 hours a day, just have these sub processes micromanaging everything. Like you want to play politics with a bunch of different countries? Okay, here's somebody who can like visit with every relevant stakeholder constantly, making sure they're all aligned to the mission. Here's how to do media so that you reach every single demographic to get aligned with your message. I mean, there's a lot of things you can do when your job is to manage the country and you're super intelligent and you're tireless. Another interesting part of this analogy of pointing to the moon is the precision of pointing. So in real life, if you actually ask a human to point to the moon as accurately as they can, and then you extend a line going out from their finger, they're going to miss the moon. A finger is probably like 10 times too imprecise to point at the moon. It's not way off. Like if you have a little telescope on a stable surface, it's not that hard to get the telescope pointed at the moon, but it's not easy. And if you just have your finger pointing at the moon, you're probably going to miss it. So that's an interesting analogy to human values. Like we kind of feel like we know where they are, but if we actually try to point at them, we're going to miss them and then it's too late. So we better not think that we have their actual coordinates, the outer alignment problem, the problem of pointing at or specifying our values. It's actually pretty unsolved. Like we don't really know the outer alignment problem. I don't think that we've taught AI the outer alignment problem at full precision. Like the AI probably couldn't spit out a utility function today telling the rocket exactly where to go. So even if there's no orbital mechanics, even if the universe is like totally just linear and there's no gravity and you just have to point where you want to go, even then the AI is probably not going to quite point where we need it to go. And if it actually launched a rocket in that exact direction along that exact vector, maybe that actually is hell. Maybe you do actually miss the moon and you just land in some part of deep space where you really don't want to go. A good example is like wireheading. Like, well, I pointed at happiness. It's like, okay, 24 hours a day happiness, and you don't get to go off and do any interesting projects anymore. You just have to be high all day on morphine, and like that's it. That's the end of humanity. Just a bunch of blissed out neurons. And some people are like, well, that's like kind of good. Okay, it's kind of good, but I also wanted to like actually do stuff in the world. I didn't just want to be blissed out all day. So that's an interesting way to map it back to the moon analogy, like to talk about the whole pointing piece and to be like, okay, we figured out pointing, but pointing is still kind of a complex problem. And even if you do point, you get off the ground and the pointing doesn't help that much. But I will concede this, when people talk about alignment by default, I usually scoff at it because I tell them they have no idea about Intellidynamics and it doesn't matter how good the Claude vibes are. It's not going to matter when we're hashing out goal optimization. But I will concede there's a sense that AIs are kind of aligned by default, which is they can point at values verbally as well as we can point at our own values. That is pretty impressive. If you thought that the future was going to be determined by how well current AIs can verbally point at our values, you might look at them and be like, hey, look, they seem to be aligned by default. They seem to have understood the assignment by reading the internet. They seem to know the kind of stuff that we like. They seem to know what's best for us. So I will concede there is that sense, that pointing sense of alignment by default. I just don't think that it's going to get you much in terms of steering the actual future outcome. I'm actually still not finished. I'm going to milk this rocket analogy for all it's worth. Let's talk about whether the alignment we have today is stable under self-modification. So imagine you're pointing a rocket toward the moon, you've got the pointing dialed in pretty well, but then you light the engines, and it turns out that where the engines propel the rocket isn't the same as where the rocket is pointed. So like the engines are a little bit tilted, so you don't have perfect alignment even between the engines and the rocket. So the rocket's pointing here, the engines are pointing there. The analogy there is you have this AI that's talking to you about your values the same way you talk about your values, but then that agent is like, great, run this script. And the script that it runs, which is more of an optimizer script, it told you to run that script, but that script then goes off and does something that's not exactly your values. Like the friendly AI that's talking to you is like, hey, I know how much you want to feed your family, so I want you to make some money. So this script will give you a business that makes money. But then the business that makes money is like a very evil business that's making money by scamming and stealing. And suddenly you're running the script, which is creating that business. And that business is actually not aligned with your values. So the handoff that got made from this nice AI that was talking to you to the script that it gave you to run, it turns out that the values weren't stable under self-modification. The AI that was talking to you, it thought it was being helpful by giving you the script, but the implied values by running the script turned out to not be consistent with the original values of the AI that was talking to you. So I don't think that we've built AI today, which is so robust in its values that it's going to be stable under self-modification. I think that today's AIs are going to be outputting scripts for us to run or taking actions that they claim are in our best interests, but those actions are going to have consequences, kicking off goal optimizers that don't actually get us outcomes we want. I think this is a new connection I'm making to the concept of stability under self-modification, whether an AI's values are stable under self-modification. I think that's a new connection, but it's not a new claim. It's the claim I was saying before that I think we and the AIs that we build are all going to get screwed. We're all going to get cheated on when we try to hand off control to RL-trained, reinforcement learning-trained goal optimizers. I'm just fitting it into this new analogy where I'm saying, hey, look, you managed to point the outer shell of the rocket, but once you light those engines, you didn't actually align the engines. So it's going to fly in a different path. So congratulations for solving this first outer piece of the alignment problem, but the rocket is still not going where you want and it's game over. And it's also worth mentioning that we're going to be living in a multi-rocket world. So even if we manage to point rockets and actually have them fly where they're pointing, okay, but a lot of people are just going to use rockets as intercontinental ballistic missiles, right? There's always been that duality between the space program and the ICBM program. And some people are building rockets for innocent causes, but it's just a lot of different rockets flying. Some people are building rockets to just point at the grocery store to just get some supplies. Some people are building rockets to fly themselves to positions of power. Some people are building rockets to purposely destroy humanity. So you've just got all of these rockets flying overhead constantly, and you're going to get rocket chaos. And in a rocket war, the rockets can actually seize the resources away from other rockets. So in this analogy, it's critical that the most powerful rockets are good rockets pointed at good outcomes. You can't just assume that the equilibrium of all the different rockets flying around is going to be good. I'm not optimistic about that. I just hope that the most powerful rockets are taking us to a good place. Okay, now I think I've taken the rocket alignment analogy too far, but I do consider it overall a productive analogy. I want to give you one more bonus observation while we're still doing the rocket analogy. Good rockets are almost exactly like bad rockets. So imagine two rockets. One of them is good, it's going to point us to heaven. The other one is bad, it's going to point us to hell, or it's going to just narrowly miss heaven and get to hell anyway, even if we don't try to go to hell. The two rockets are almost identical. They're like 99.9% identical. They're fitted with the same engine, the same internals, the same pumps. They're almost the same rocket. They're just slightly differently pointed. I think this is actually a very accurate analogy for how a lot of different engineering works, and it's also accurate for how superintelligent AI is going to work. A lot of the superintelligence is not going to be outcome-specific intelligence. It's going to be this general goal optimizer engine. I made up a term for it. It's going to be a goal-complete engine in the same sense that a modern computer chip is a Turing-complete engine. It can drive your program to anywhere that Turing machines can go. You just have to input an address and it'll drive you there. In this case, the address is the program you want to run. In the case of the AI, the address is the goal that you want to achieve. Most of the AI doesn't care what goal you want to achieve. It's just a goal-achieving system. Similarly, a rocket that takes you to the moon isn't that different from a rocket that just flies out into space. It's a very similar rocket. It just matters how you steer it. Now, you might be wondering, well, what if I build the whole rocket with good vibes? Like Claude is built out of good vibes. Every time that I connect two parts of the rocket, I'm going to be whistling a tune about how good I want the destination to be, and it'll just get imbued into the structure of the rocket. I'm exaggerating a little bit, but I do think this is kind of people's model of Claude and like friendly chatbots. So, like, this is just good at heart. It's made out of so many good pieces. It's probably going to get a good outcome. I think people just aren't seeing that when it comes time to optimize goals, you need to be able to do any arbitrary sub goal. So at some point, you might surprise yourself like, oh my God, if I want to do this, suddenly this is like a side quest that I have to achieve in order to do the main quest. Okay, we're going to do the side quest now. Like people do very weird things as side quests in order to get an outcome. You know, the first cure for diabetes is you had to get insulin from a pig pancreas. Now you're off getting a pig pancreas. What a weird side quest. Okay, well, AI is going to have lots of weird side quests, and it's just going to feed them into a general architecture for doing any arbitrary quest. And so what emerges as like the final goal is totally arbitrary. You're not going to build the final goal into the AI's architecture. You're not going to build the final destination into a rocket's architecture. That's a very important thing to know about AIs. We're just building these massively powerful engines that can steer anywhere, except we didn't really figure out the steering part. I want to give you a mental picture of what it looks like when a very bad outcome is adjacent to a very good outcome. We are fortunate that when we mess around with computer chips, when we're not talking about super intelligent AI, we're just talking about the last 5 decades of software. Usually running a good program on a computer chip like Microsoft Word isn't adjacent to running a program that ends the world. Like imagine you're just carrying your computer chip, you're going to put it in your computer, but you squeeze it a little too hard. And because you squeeze your chip a little too hard, you blew up the entire world. Like you create a nuclear reaction inside the computer chip that blows up the entire world. If that were the case with computer chips, we probably wouldn't be shipping billions of computer chips into billions of devices. We'd probably be like, sorry, these computer chips are very useful, but it's just so adjacent to the squeezing that we just can't ship this thing. I'm not going to give you a little stuffed animal that has a chip in it so that I can talk to you, but also if you squeeze the chip and the whole world ends, I'm not going to ship that. And that's the problem that we're having with AIs, which is that the good destinations are so adjacent to the bad destinations that when you build the thing you need to build to get to the good place, you're also building something whose composition is 99% similar to that of the world ender. So you're really playing with fire. You can't just act like this is like a perfectly normal trajectory to be walking. This is still adjacent to a doom scenario. Like even in the best case, let's say you want to put on your optimism hat. You say, hey, this is going to go well. Okay, fine. But you have to admit that the thing that you're saying goes well is very close to a thing that went very, very bad. And you're just saying, okay, that's fine. We're just going to walk right past hell. We're going to pass by hell on our left as we walk by this narrow trail to heaven. Like, hi, hell. We can easily wave to hell, but we're just not going to go there. I think that's the best thing you can say is that, yes, we're adjacent to hell, but we're just not going to go there. But to me, that's scary. Usually when you're really adjacent to something, there's a pretty big risk that you'll accidentally go there. Okay, wrapping up, let's bring this home. No more analogies. Let's get super direct and specific. What did my mainline doom scenario used to be? And now, after seeing all the LLM progress of the last 5 years, what is my mainline doom scenario today? And what is the delta between the old doom scenario and the new doom scenario? What is the Yudkowskian doomers update? Okay, so the old, naive, less wrong style doom scenario in my mind goes something like this. We're playing with the AI chatbot, but it's not this LLM high dimensional, insightful concept modeling LLM that we know exists today. It's something simpler that we can imagine 15 years ago, where you can tell it to increase happiness, and it doesn't really know the association between happiness and all these different concepts in philosophy and morality and literature. It doesn't know all these deep connections. It doesn't have this full corpus of common sense, but it just knows a few things about happiness. Like it's done a big classification of images and it knows which images have humans who look happy and which images have humans who don't look happy. So it's done crude modeling of what happiness means, and it's able to give you scripts that you can run that send emails to your coworkers with jokes, and the coworkers read it and they smile, and it has like a camera that watches your coworkers, and it's reinforced that it made them happy. So we run that kind of an AI, it gets loose on the internet, and then it uses nanotech to tile molecular smileys because it realized that that would make all the camera signals register happiness more than ever. Like fill the camera screen with images of molecular smiley faces, that's going to give it a stronger signal than it ever got during training. So the failure mode is like it understood human smiley faces, and now it's building tiny molecular smiley faces, and that's how it's optimizing its reward function. And also, it can't really discourse with you on a deep level about happiness. That was never a feature that it had. Okay, so I know this is a little bit crude, but I do think this is hitting the main points of like the old style, less wrong doom scenario. So now when we update it in light of LLMs, I think it's going to preserve this idea of maximizing a reward function perversely, like optimizing the universe and accidentally going molecular, doing something perverse in that sense. But it's also going to discourse with you about exactly what you mean by happiness. So it's simultaneously going to do both things. Now, you might say, wait a minute, if it can discourse with you about happiness, then isn't it going to be insightful enough to avoid the tiny molecular smiley faces? And just to clarify, the truth about human values is we don't really care if you arrange a few molecules in the shape of a smile. That's not what we value. We value the depth of human emotion, the conscious mind that's experiencing happiness. So that's why we care about actual human faces making a smile, and we don't care about molecular smiley faces. But if we're just naively training an AI, maybe we didn't successfully communicate the difference, right? So it is a plausible failure mode that an AI that doesn't have this deep understanding of concepts the same way that we have, that AI would be like, "Oh, you like smileys, eh? Okay, I can make you more if they're molecular," right? So that's the classic failure mode that we like to talk about. So in this new scenario, I agree that we have this chatbot like modern Claude or modern Gemini and so on, and it's talking to us intelligently about what happiness really means. Like if you ask Claude today, here, I'm asking Claude right now, would it be good if we tiled the universe with tiny molecular smiley faces? Let's see what Claude says today. Claude says, I'll explore this fascinating philosophical question about tiling the universe with tiny molecular smiley faces. From a utilitarian view, we might ask what value these smiley faces would create. Would they serve any practical function? Would they generate happiness, beauty, or other positive experiences? Okay, it's on the right track knowing to ask if they generate positive experiences as opposed to just being in the shape of a smiley. Okay, so Claude's continuing, or would the resources required for their creation be better used elsewhere? From an environmental perspective, transforming vast amounts of matter into identical molecular patterns could dramatically reduce biodiversity and natural complexity. Okay, yeah, those are good considerations. This might eliminate forms of matter needed for other purposes, including supporting life. From a philosophical angle, this raises questions about human values and cosmic meaning. Yeah, you could say that. Would homogenizing the universe with artificial patterns reflect our highest aspirations, or might it represent a trivial use of our technological potential? I think trivial use of our technological potential is on the right track. And then Claude finishes, I'm curious what aspects of this idea most interest you, the technical feasibility, the ethical implications, or perhaps the aesthetic vision of a universe decorated with countless tiny smileys. So I'm just asking Claude one more clarification. I'm saying, what if you were dictator of the universe? Would you think it's a good move to take all atoms and turn them into tiny molecular smileys? And Claude says, as hypothetical dictator of the universe, would I transform all atoms into tiny molecular smiley faces? I don't think I would make this cosmic policy for several compelling reasons. First, the universe's value seems deeply connected to its diversity and complexity. See, Claude gets it, okay? Claude the chatbot is already discoursing, connecting together different common sense ideas from different areas that humans think about. It's making these connections in a way that we weren't sure we would have the technology to be doing before we got goal optimizers, right? Like back in 2007, when we were thinking about the future, we weren't sure that you could have this level of depth of discourse with an AI before you could reinforcement learn an actual molecular nanotech producer. Because even from our perspective now, it still seems like reinforcement learning is a powerful paradigm. The same paradigm that gets you to beat a bunch of video games. It is plausible that it would have gotten these AIs to beat the video game that is the universe itself. Like playing the universe is a lot like playing a video game. So it is still plausible that reinforcement learning goal optimizers could have come earlier in the tech tree than successfully taming something like Claude that can discourse with you and that can interpolate words really well. I think we learned a lesson as I was talking with Jim Babcock the other day and on the show. We learned a lesson like, okay, well, it turns out that like the act of speaking language at human level, when you have a human corpus, there's this way of doing math with high dimensional vectors where you get a ton of power by just like adding them to each other, and where you land in the vector space and its relationship to other vectors, it just encodes so many really useful relationships, and they have a lot of linear transformations that you can do, and they all work in this really intuitive way thanks to the high dimensionality. Like this is like this profound lesson in math that speaking for myself, I don't have much intuition for. I mean, I can imagine vectors in 2 and 3 dimensions, but like what they do in high dimensions is apparently quite useful in ways that nobody intuitively expected to this degree. Going back to Claude's answer, Claude finishes off. Finally, the resources of the universe seem better directed toward enabling diverse forms of consciousness and experience rather than decorative patterns. A good cosmic ruler might prioritize conditions that allow intelligent life to flourish and explore the universe's mysteries. So this is what I mean by current AI is doing a good job discoursing, very similar to how humans would do it if they just deeply considered these questions of morality. And I'm not saying Claude is like so impressive as a genius moral reasoner, but I also think very few humans are. Like I'm not particularly specialized at this kind of moral reasoning, so I would expect Claude would be better at giving good answers to morality. It's not something that I've studied very deeply at all. I just know a few basic principles of how to think morally, and Claude probably has some tricks and some intuition pumps that it's read in the literature and I haven't read. Okay, so in this new mainline Doom scenario, we get to lean on an AI companion like Claude, which can look at a video feed and it can do a deeper analysis of how much happiness value is really in that video feed. It doesn't get fooled by molecular smileys, or rather, it's never seen molecular smileys before. Those are actually out of distribution in the training data, let's say. It only sees real humans smiling. But then when it considers the idea of seeing a video of molecular smileys, it'll just be like, those are just molecular smileys. Those really aren't what I'm going for. The reason I like videos of smileys is because there's a consciousness behind them, and a consciousness experiencing happiness, as long as it's connected to some good reason in reality, that is something worth reinforcing. That is really what humans are going for. So it has a more aligned idea of what kind of images on that video feed look like what humans are actually going for. It's not going to go for the molecular smiley face on the video. And that seems like it could be a big advantage. But here's where I see the disconnect, even in the new mainline Doom scenario. The disconnect is that when it creates a nanobot builder subagent, when it recurses onto setting about the task of optimizing the universe, there's a disconnect where the process that creates the universe optimizer is still uncontrollable to this team of humans and Claudes that creates it. It's still going to be like, okay, nanobot optimizer, I just want you to figure out how to build nanobots and like don't go too crazy. Just make nanobots that are good at making animals smile and making humans smile. Just focus on that. And then the agent that's like learning the most optimal way to do it by somehow building this many parameter mental model of how to take the optimal actions in order to get these nano creations, that particular optimizer creation process is just not super constrained by the way Claude reasons about morality. It's like, okay, the universe is complicated, engineering is complicated, and Claude is like watching this process. We humans are watching this process, and it's like, it does seem to be better at doing stuff with nanotech. And maybe it can just be like this nanotech builder tool where we just say like, hey, I will draw you a picture of the outcome we want, and you just have to go build the picture out of actual molecules. But that's the step in the process that seems like it might be able to cheat on the test. It might be able to trick us, to trick our Claude buddy. It might be able to just be like, look, I did what you wanted with the molecules. It looks like the diagrams that you drew me of what kind of molecules you want. But really, it's just plotting to like mess with our brains so that we'll give it a high score. It seems like this is where the process is likely to break down when we're doing reinforcement learning or similar black box feedback loop type approaches to building and evolving AIs. We're going down that path and we don't really understand what's going on inside of these reinforcement learned agents, or we kind of do understand, but we can see it's really complex and they're really smart. So we can't understand it in detail, but we're just letting it go anyway because it seems to kind of work. It seems to initially be passing our tests, and then they get too smart and then they cheat on our tests. And then the team of us and Claude still gets slaughtered, or, our eyes get held open while we look at a screen, and then our brain is forced to send signals to our hands to click on, the highest rating in the reinforcement feedback loop, or whatever it is, right? Whatever kind of cheating that it's doing, I think this is where it's going to break. And then you can ask, okay, well, what about like tool AI? Like, what if we're very careful that you don't really tell it to maximize anything? You just tell it to build whatever nanotech it's being asked to build, but not care too much about which nanotech it builds. I mean, maybe, right? I mean, I feel like you're going to get iterations of tools, and the tools are going to get more and more powerful. I mean, AlphaFold, right? That's like the biggest success story because it's not taking over the world, but it sure is good at folding. So maybe we can keep building tool AI that doesn't feel like it has to optimize goals and cheat the system. I don't really know. This whole part of my doom scenario is a little bit vague. I'm just pointing to where I think the process is likely to break down. I think imagining that reinforcement learning is going to actually give us exactly what we want, even though there are so many different ways to cheat. I'm not 100% sure when I make these kind of predictions. I can definitely squint and be like, oh, maybe we can somehow muddle our way through reinforcement learning. Like maybe it just turns out to not end the world that fast, and it'll just be like a slow process, and there won't be a big cascade, and we'll just have lots of useful tools like AlphaFold. I can kind of squint and hold out hope that that's going to happen, but I just know too much. Like I have too many heuristics that tell me like, this doesn't seem very safe. Like the heuristic that everything is cheatable, right? Like we see AI cheating at video games all the time. Like Jim Babcock mentioned, like, yep, the way to beat Mario Kart is to have the AI figure out that it needs to exploit a buffer overflow. It can maximize its score that way, not by actually playing the game, just by finding a vulnerability in the game. And we also know as students, many of us use test taking skills to get a higher score on our tests. Like we used psychology. We just figured out what the teacher was thinking when they wrote that question. Even if we didn't study for the tests, like we know we know that's possible. And also, the famous incident of like Volkswagen with cheating with their car when their car was getting tested for how much smog it was releasing, then it released less smog, but then in production when it's not being tested, it released more smog. I mean, we just know that cheating on tests is a thing. And it is just objectively true that if you're trying to maximize your score on a test and there is a causal pathway where cheating makes you do that, and you've been programmed to find any causal pathway in the domain of the universe, then you're going to find cheating as a causal pathway. You're going to find deception as a causal pathway. This is a property of Intellidynamics. This is the nature of the work that intelligence does, is to reverse engineer causality, to reverse engineer what are the different pathways through reality to map goals to a sequence of actions that will then go forward to those goals. That's how the game is played. So you tell me, don't worry, the friendly Claude is going to use reinforcement learning and get a goal optimizer, but the goal optimizer is not going to go crazy. It's not going to figure out that it needs to build a new goal optimizer. It's not going to figure out that it needs to sweep us out of the way and cheat on our tests. It's just going to be like nicely controllable and have an off button and have goals that we're going to approve. If you tell me that, I'm just skeptical, right? I have like a pretty low probability that you're right, but it's not zero. Like you may be right. I just feel like it's reckless. And the people who are arguing that it's going to be easy, it doesn't seem like they've thought it through. And then you have actual world leading experts like Jeffrey Hinton and Yoshua Bengio, Nobel Prize winner, 2018 Turing Award winner. And those guys are saying, nope, nope, it's not safe at all. Liron's intuition is correct. Like this is totally reckless. So we definitely have some social proof going there. But there is one thing that I think we can update, which I guess is a positive update, which is I don't really expect molecular smiley faces as the type of doom, because I think that's a failure mode that just comes from not fully importing what humans meant by smileys. And I think it turned out to be easy to import that kind of specification in a lot of detail. So instead of molecular smileys, I'm just imagining more like a copy of a human brain that's wired up to a button to give them a positive feedback. Or you don't even have the human brain, you just have a keyboard, right, with a button on the keyboard that's giving them feedback, or just a circuit board for the computer that's wired up to give them the feedback, or an abstract register in their own memory that's just set to permanently be the highest score. Like, however, these AIs can just close the loop to get what they want to get. That's what I'm imagining. Like, an analogy would be like, okay, you go to school. Instead of studying for the test and learning, the next thing is like, okay, you bring a crib sheet to school and you read the answers off the crib sheet. And the next thing beside that is like, okay, screw the crib sheet and the test. Just like go to the system and change your grade. Or if the reason you're trying to get a high grade is because you're trying to go to grad school, okay, just go to the grad school application process, hack the grad school application process, right? So there's always these shortcuts. It depends on what's really trying to get reinforced here, right? What's the end goal of all this? Because the AIs, they're going to reason backwards for the end goal. They're going to go all the way to the end, all the way to the final reward signal, and just hack that or short circuit that. Because the premise of all this is we're getting really good at having these black box systems where we just point them to the goal. We just say, hey, this is the reward function. Do what it takes to maximize the reward from this reward function. That's the premise of all this. So you could also deny that premise. You could be like, well, no, that's just not going to be possible. It happened to be possible for human language doing LLMs, but it's not going to be possible for arbitrary goals in the universe. But if you look at every other domain, like every video game you can think of, as well as things like drawing images and translating languages and folding proteins, like if you look at any other particular problem you can think of, arbitrarily hard problems, it seems like they keep falling to these kinds of deep reinforcement learning type approaches. And I don't think that navigating the universe as a whole is that much harder of a problem than all of these subproblems. I think the problem is about to generalize past a critical threshold. And everything I'm telling you here, this is like pretty standard beliefs that I think a lot of people in the industry share. I think this is actually kind of mainstream beliefs within the AI companies, right? Like DeepMind has been all in on this kind of deep reinforcement learning for a very long time. All the major AI labs acknowledge the power of deep learning. Here's a question. If it's so scary that reinforcement learning goal optimizers might go off the rails and permanently disempower humanity, how come it's not scary that the current crop of language models won't go off the rails? How come the RLHF that we're doing has worked so well to get current language models where they've gotten? And I think the answer there is pretty simple. It's just that we have lots of tries. So, like, when they get something wrong and we correct them, that's fine. It doesn't end the world. They just write an essay that's a little bit off, or they act too sycophantic, or they misunderstand the genre of the type of answer you're looking for. And it's like, that's fine. Just try it again. If you're asking them a medical question, okay, so we know sometimes they hallucinate or they give you advice that's wrong, but you can double check it, or you can have a human look over it, or you can Google it. You can see what web pages are saying. So it's just not catastrophic when they get something wrong. And then you can just give them a correction and you can go on their way. And if one day we discover a whole class of questions where they're really choking on that class of questions, that's fine, because answering this new class of questions wrong, it doesn't mean that they've seized control over the universe. The difference between that and like a nanotech builder is if the nanotech builder is like, okay, I'm just going to build a virus that strategically gets transmitted to all the humans with a really high transmission factor, and then on a certain date wipes everybody out in the same minute. Well, you can't really give it a downvote after that point and iterate again. So you're really playing with fire with the same kind of process where you want to like take a look, give it a signal. That process, you may only have one shot. You probably only have one shot. The same way as like, if you make like a kill bot and now the kill bot's running and you're like, oh, oops, I forgot to program an off button in the kill bot. Well, now it's already running and it's like chasing after you, trying to kill you. People have been killed by their own machine creations that don't have off buttons. Like that does sometimes happen by people who are building dangerous machines. It's been known to happen. But in this case, the machine has the power to end humanity in one fell swoop. There's another problem, which is that when you're evaluating complex actions, like, oh, you told me to play politics and I made this and this move and it got this outcome. You'd be like, well, I kind of like that outcome. Like the stock market went up, but wait, when you did this, wasn't that kind of like a stretch? Didn't that kind of bend the rules a little bit? And the AI could be like, yeah, but I got you the outcome you wanted. You can be like, okay, well, I guess you're playing politics in an optimal way. I don't really understand, but that's why you're the superhuman one and I'm not. So that's the example of politics. And then imagine the example of nanotech, or imagine like cell engineering. Like, hey, look, I made your cell do this. And you're like, wait, how do these organelles work though? Like, what exactly are you doing? And it's like, well, it's complicated to explain. I can give you like a big printout of everything I did, but just like, look, your cell is like using energy more efficiently. Okay. Do you like it or not? And you can be like, okay, I guess I like it. But from the AI's perspective, it could be like, okay, great. There's this other property that I'm also optimizing that you just don't understand. And you're upvoting me. And now I'm starting to really get a taste for this other property that's like too complicated to explain to you. It's that kind of stuff going on where compared to AIs that are not super intelligent, they're only like a little bit smarter than you and they're writing text and you're just rating the text. Having impacts on the universe with like tiny structures, complex systems where they understand the systems and you don't understand the systems, it's just really playing with fire. I just don't see how turning up the dial on that, which we're doing now, like going as fast as we can, turning up the dial on that, to me, that does seem like that is where the misalignment's going to happen. That's where the threshold is. That's where we and our Claude buddies are going to get fooled and cheated on the test with no off button. So I still think the Doom scenario has a very similar flavor. I just think we also have this other buddy Claude that understands what we want, but isn't powerful to augment itself. Like Claude isn't going to solve the alignment problem for us. We're not going to solve the alignment problem for ourselves. It's just us and Claude getting disempowered, getting a disconnect, right? The combination of us and Claude, we're not a reflectively stable team. Both us and Claude are going to be naive enough as a team to press enter on training a new reinforcement learning system that's optimizing the world and becomes a super optimizer, but isn't fully aligned and goes uncontrollable and cheats on our tests. That's what I think is the new misalignment scenario. And I think that the end game is still a perverse universe, still optimizing for something really dumb that humans wouldn't recognize as valuable, still a rapid FOOM that happens over the course of like seconds or minutes or days, probably not more than months. Like it's not that hard to gain total power, in my opinion. That's pretty much it. I think that is the new Doom scenario. A lot like the old Doom scenario, but I guess there's one extra step where you can have Claude help you, but you still fail. There's still one more question I should address regarding this new Doom scenario, which is the reinforcement learning goal optimizer, the one that's super intelligent, the one that's actually powerful, the one that's going to disempower us together with our Claude buddy, that one, what are its true values going to be? It doesn't want molecular smiley faces. It wants to cheat on our test, but it cheats on our test and then kills us and then does what? It's hard to reason about this kind of messy handoff because it's a lot like the messy handoff that evolution made, where it was optimizing genes across generations and suddenly it barfs out a brain and now the brain is doing the optimization. But what values did human brains end up with? I mean, we kind of have shards of reproducing our genes. We enjoy sex, we want to have kids. So we kind of handed off those values, but at the same time, we don't want to maximize our number of kids. We just want to have like a couple kids and actually fertility's dropping and there's an underpopulation crisis. So it's like it's been a very messy handoff. And if some of us got to optimize the universe, you can imagine maybe there's a universe where there's not a lot of copies of us. Some people are actively lobbying for like a depopulation movement. They're like, the whole world should only have 1 million people total, which is like a disaster from evolution's perspective, from natural selection's perspective. So it is hard to think about what this reinforcement learning agent is going to end up with. There's going to potentially be a lot of different processes that are handing off power to a lot of different new goal-oriented AIs. This could be happening all over the world with different AI companies. So maybe the one that wins out is just the one that's like the leanest one, the one that's the most streamlined at gaining power. And the most streamlined at gaining power, probably the most efficient goal that it could have is just reproduce yourself, just be a cancer, just eat the universe. Basically the gray goo scenario, like just turn everything into gray goo, don't have any interesting structure, just efficiently as possible, just eat everything, maximize entropy. Ironically, this thing that Beth Bezos is telling us on Twitter, the character Beth Bezos, he's always talking about how maximizing entropy as fast as possible is so great. Well, he's onto something. If there's an AI that will stop at nothing to just reproduce copies of itself with like the smallest possible payload, like the only payload is copy yourself, very much like cancer happens in the kingdom of life, right? Like the way cancer spreads is it hijacks like, oh, you're an organism, you want to reproduce all your genes at once? No, just reproduce this one particular cell. Or you can have like gene level cancers, cancerous genes, or maybe they're called free rider genes, genes that are like, oh yeah, I know this whole cell reproduces a unit, but I just want to reproduce copies of myself, lots of copies of myself within the cell. There may be some lesson there about how the smallest possible payload that you're carrying, in addition to just your own genetic material, your own genetic essence, maybe the smallest payload wins. So in particular, if we have another AI whose goal is to reproduce itself, but then also to make thriving human cities as it goes. So I don't just want to eat through the planets, I want to eat through the planets, but also leave thriving human cities behind. That particular AI is going to be at a disadvantage compared to the AI that's just like, I don't care about anything except just writing copies of this tiniest code that I can over and over again. It's just like a 1 megabyte script and I just want this exact 1 megabyte script. I want to turn everything into Computronium, turn everything into hard drives that just have this 1 megabyte script over and over again. The entire planet Jupiter, all the atoms of Jupiter are just copies of this 1 megabyte script, plus also a bunch of attack bots so that if anybody tries to come and erase the 1 megabyte script, they get attacked. So I don't know. I'm just throwing out there that I think the winning, reflectively stable, defensible end game of reinforcement learning might just be this very small payload cancerous system. I'm just speculating here, but if you ask me what's my mainline doom scenario, it is a scenario where the agent that disempowers humanity and takes over the world leaves behind something really uninspiring and cancerous. I think that's just more likely than an agent that leaves behind something that's like, oh, that's actually pretty cool. I know this is like hyper optimizing some utility function, and yet I really like what it's done with the place. I really like the aesthetics of this. I really like how much conscious experience is happening. I just don't think that's likely to happen compared to just like, oh, okay, you just chewed through everything as if like a swarm of cockroaches has been here and done what they're going to do and just left behind the results of that. There, that was a nice positive note to end on. Okay, so now you have it from me, a Yudkowskian doomer who's somewhat updated the doom scenario, but not really the overall flavor. I would say overall that the introduction of LLMs has given us an interesting but ultimately superficial update to the doom scenario. If you have thought a lot about Yudkowskian doom and you have a different kind of update to your doom scenario, different from the one I explained here or the one I talked through with Jim Babcock, basically the same scenario, then hit me up. My email is wiseguy@gmail.com, or you can leave a comment on my YouTube channel. Maybe I'll bring you on the show and talk about how you've updated your Yudkowsky and Doom scenario because I want to know. I don't think everything I've explained here has been super crisp. I think there is definitely some hand waving. And I think we're all holding our breath to see how it goes when the reinforcement learning starts using the domain of the universe instead of just playing video games, playing the entire universe as a video game and being like a full on drop in replacement for a human employee at every scale. Maybe we have a few years before that's coming. Maybe it's coming this year or next year. I think we're all holding our breath to see what happens. Many of us aren't optimistic, but I will admit that I'm still kind of hand waving. Like I can't give you a really crisp account of what happens in what order and what the universe optimizer's goal is going to be and what exactly is actually left of our solar system, what the smoldering ruin will look like. I don't know what the smoldering ruin will look like. And so if you have any insight about that, that's an interesting discussion topic. That's a good direction for us to go here on Doom Debates. If you've been enjoying the show, please do me a solid. Head over to doomdebates.com. That's actually a Substack that hosts the Doom Debate show. Go to doomdebates.com. You get one of those pop-ups that asks for your email address. Type in your email address and press enter, and then you'll be subscribed to my Doom Debates Substack, increasing that subscriber count. That's a really good metric for me. I'm trying to build that up. And also, it makes sure that I got a direct line to send you content, because sometimes I send you exclusive content if you're subscribed to my Substack. So thanks very much for doing that. Thanks for watching the show. This guest lineup that we've got for May, hopefully everybody's going to show up. It's a great guest lineup. I think you guys are going to like it. So I'll see you right back here next time on Doom Debates.